Welcome to our in-depth exploration into the darker side of renewable energy storage, titled, Batteries Are Not Green: The Dirty Secret of Renewable Energy Storage. In this video, we will shed light on the environmental implications of battery production and disposal, challenging the widespread belief that batteries are a wholly green solution. Through a comprehensive discussion, we aim to redefine the narrative around renewable energy storage and navigate towards more sustainable alternatives. Buckle up as we delve into this complex issue that is more than meets the eye. 1. The reality behind electrons. Where do batteries fit in? When we think about renewable energy, we often picture wind farms sprawling across vast landscapes or solar panels glittering under the sun. It's a clean image. However, behind these clean systems lies a hidden truth: batteries. Batteries are the key component in storing renewable energy, but they are far from green. On the surface, they seem like the ultimate solution for energy storage, yet the way they're produced and disposed of tells a different story. For instance, the mining of lithium, a critical component in batteries, leaves a massive carbon footprint and significantly disrupts ecosystems. Moreover, the energy consumption in manufacturing batteries negates some benefits of being green. 2. Mining for elements. Digging deeper into environmental impacts, the process starts with lithium extraction. Lithium is critical for battery production, and its extraction is energy-intensive, involving water-heavy mining practices. Imagine a metal straw in a water glass. That's akin to the massive water removal necessary to obtain lithium. The regions rich in lithium, such as parts of Chile and Bolivia, face water shortages as a consequence, drastically affecting local communities and agriculture. Equally concerning are the other elements like cobalt and nickel, which carry their own environmental baggage. As demand for these materials rises, so do tensions over resource exploitation, raising ethical questions about renewable energy's true footprint. 3. Pollution prevails. The toxicity of manufacturing batteries. Once the precious elements are gathered, they move to factories for processing. Battery production itself generates hazardous waste, which often ends up in landfills, contaminating soil and water sources. Chemicals such as sulfuric acid used during the process can persist in the environment long after production stops. Moreover, the energy used in these factories often comes from coal or gas, overshadowing the environmental benefits that renewable energies aim to provide. As transparency grows and the public becomes more educated, the irony becomes clear. While these batteries power clean energy, they are born from not-so-clean origins. 4. Lifespan limitations. When batteries die, Mother Earth pays with time. Batteries degrade. Their lifespan is not infinite, usually ranging from a few to about 10 years, depending on usage. Unfortunately, end-of-life management often includes incineration or landfilling. Picture a car graveyard, but with old batteries. These practices release toxic chemicals into the environment, disrupting ecosystems and posing significant health risks. While recycling exists, it's often not cost-effective, and only a tiny fraction of batteries actually get recycled. Economic and technical hurdles mean the rest simply contribute to the growing problem of electronic waste. 5. The cost quandary. Financial spin on a green illusion. Beyond environmental concerns, there's a financial strain. The cost of producing and maintaining energy storage systems is high. Though efforts to reduce costs continue, batteries remain expensive to both produce and recycle. Subsidies often mask these costs, painting a picture of sustainability that isn't entirely accurate. Consumers and stakeholders sometimes find it frustrating as these costs are passed on, making renewable energy seem less affordable in the long run. This financial burden can seem like paying more for what seems to be a green alternative, making the transition toward renewables less attractive. 6. Technological tides. Striving for sustainable storage solutions. Despite the challenges, there's a ray of hope with innovations. Researchers are looking into alternative battery technologies that could reduce reliance on harmful materials, like solid-state and flow batteries. These technologies promise higher efficiency and sustainability if hurdles like cost and scalability can be overcome. Some envision a future where more sustainable materials, like sodium, replace lithium. However, these advancements are still in their infancy, and mainstream adoption could take years. The race for alternatives signifies the growing acknowledgement of current battery technology's limitations, sparking a quest for genuinely green solutions. 7. Land use and landscape. The visual and cultural footprint of storage solutions. The infrastructure required to store renewable energy can be quite invasive. Large battery storage facilities occupy vast areas of land that might otherwise be used for agriculture or wildlife habitat. This land use shift affects not only the environment but also cultural landscapes. Local communities often face the double-edged impact of having greener energy solutions but losing lands that hold cultural significance or provide livelihood. Sometimes, even basic aesthetic alteration of landscapes can spark resistance among communities, pointing to a broader tension between development and preservation. 8. A time for change. Assessing the path forward while challenges exist, awareness is the first step toward change. Realizing that batteries aren't the green energy solution opens up dialogues on improving storage methods. Governments, companies, and researchers are increasingly focused on the development of alternative energy storage solutions that could be less impactful on the environment and society. Investing in these new technologies is vital for a sustainable future, with the hope that someday we might rely on genuinely green energy storage systems. Acknowledging the dirty secret of battery-powered energy storage is crucial as we tread this path toward true environmental sustainability without greenwashing.